Okay, so I added a couple of web pages to explain sigma and pi notation for summations and accumulative products. So if you start at my main page here, tjleone.com, and go down to mathematical puzzling with Python, and go here and click on sigma, that'll bring up this page. And well, there's a few things on the page. There's a file you can download that has a simplified version of sigma. It's simpler than the one that's in the appendix. It's actually this one right here. And there's an explanation down here. So basically I have these functions written up in Python and also algebraically. So I have this function define f of x as 2x plus 1, and down here it's f of x equals 2x plus 1. And g of x is x, the quantity x minus 1 times the quantity x minus 3. That's written this way algebraically. And the sigma function adds together, takes one of those functions, it'll take any function basically, and add together all the values one at a time. So I think what I want to do is just walk through, just step through this a little bit. And like I said, you can go to this page and play with it yourself. The way it works is it's going to step through the Python code. So there's a little bit of a faded green arrow that tells you that a line has just been executed, and the red arrow is on the next line to execute. So we're just starting now, so we're just pointing at line 1. We're just about to execute that line. So if I click the forward button, it executes that. Okay, so we just executed line 1, so it's got this little green arrow, and we're down about to go to line 4. So let's see over here what happened with these frames and objects. So what happened was we created a global variable called f that points to this function. Okay, so when we so for example, right here we'll see later, when we use f as input to something, it's going to pass a pointer to this guy. Okay, so now we're going to define g of x. We created another global variable g that points over there, and then we're going to do the same with sigma. Okay, so now we have basically 3 global variables, and they're all function names. This one goes to this function, g goes to that function, and sigma goes to this function. Now we're on line 13, and we're going to actually make a function call. So here we just set things up and initialize these global variables. Now we're going to actually make this call to sigma. So we're calling sigma with f, that's the this global variable right here, this function, a pointer to this function, and then 2 and 4. Okay, so let's go to sigma then. So now what happened? Well, now we passed in f. So this that's our first parameter here. So function. So this points to that function f. So this. So you notice we have this variable, this global variable f, and function now both point to the same thing. So this function is actually what happened was we passed f, and so now when we talk in this time, while we're in sigma, function points to this f of x. Okay, so the first thing we're going to do is say result equals 0. Oh, and what else did we do? Our from parameter has the value 2 because we passed in 2, and our to parameter has the value 4. So we're going to go from this number to that number. Basically, that's how sigma works. So we're going to go forward. We set result equal to 0. And now we're going, notice I put for I in range from, and then I said 2 plus 1. That's because we want to include the last number. So the way sigma is defined here when it says the sum from I equals 2 to 4, that's inclusive. So we want to do 2, 3, and 4. So we want to include that last value. Okay, and normally if we did for I in range whatever, the range doesn't gives us, we need one more number to get that. So actually we need to, for I in range, going from 2 to 5 actually, and then it'll do the right thing. It'll stop at 4. Okay, because it stops like one short. Okay, so so now we just set result to 0, and now we're about to execute line 9. Okay, and we're so we set I to 2. That's the first value, right? Because that's our from, and we're going to keep going until it hits. We want to keep going until it gets to 4, right? So here we say result plus equals function I. Now remember, this function points to f. So we're going to bounce up here. So now we made that call to f, and we remember our I was 2 at this point. So we're calling f. So now f gets 2 as its x parameter there. Okay, we step through, and we return a 5, because 2 times 2 is 4, plus 1 is 5. Okay, so that's our return value. Then we step through again. So now we're back to our loop. So we return from this, right? And we set the function. Now notice result is now 5, because we returned a 5 from there, and result was result started out as 0, so we added that 5 in there. So now we're going to loop through again. Now our I is 3. So we're basically going to do the same thing, but now with x equal to 3. We go through. 2 times 3 is 6, plus 1 is 7, so we're going to return a 7. There's our return value. And remember, we're returning here. This is where we're making the function call. That function is going up to f. Okay. And oh, and then we increment I again to be 4. Okay. And that goes up there. So now we have 2 times 4 is 8, plus 1 is 9. So our return value is 9. And now we have 2 is 4, I is 4, so we're going to fall out. Okay, so basically the way this for I in range works is it goes to just before this last value here. So we're going to return result. Our result is 21. So our return value is 21. And so that's what came back from our sigma. So now we're done with this sigma, and we're going to run this one. So let me just show you that 21. That's what we got here when we added together all of these guys. Okay. So you can step through this one too. Now notice this time our function, because we passed in g, we passed in the function g, now this function parameter here points to the function g. Okay, but we're basically going to do the same kind of thing, except now we're going from 1 to 3. Okay, so you can play with that. You can also download the .py file that has all this in it, and play around with that if you want. Change around the numbers. And there's also a prod version of this too that you can play around with. And notice that prod starts with a result equal to 1, right? Because 1 is the identity in multiplication. When we do our first multiplication, we want to make sure whatever this value is, that result becomes that, and then we just keep multiplying. So it's a similar idea. Here's the algebraic expression of everything. So hopefully that'll make sigma and prod clearer to what's going on with them.